Hello everyone, welcome back to another new video. We have a most important question, and this question is taken from the past old question. Okay, and this question is asked in 2019 fall and 2021 fall, and such type of question is repeatedly asking in our university examination. So let's go for the solution. You can see here we have a program related to two integers in given question. First, read the question. Okay, so we have a question of 2 inch arch. 2 inch arch. We have a given 2 inch arch. Okay, constructed in Tino River, Butwal. The center right was found to be 1/10 of the span. Okay, so here you can see the important thing is given here. The center rise is 1/10 of the span. It means from here we can easily write first. Let us suppose the length of this span. Suppose we have a given span. Okay, let us assume. So this is the length and this is the center rise. Okay, so in both sides, a horizontal thrust will apply. Okay, and you can see here in the given question said the center right was found to be 1/10 of the span. If the span is L, the length of the span is L. Suppose here to here is L, then this central height will be 1/10. It means this will be L upon 10. Okay, so H will be L upon 10. Okay, according to question, and L is the length of this span. Okay, so this is said by the question. Now the span of the arch was taken equivalent to the span simply supported beam. You can see here simply supported span is equivalent to the simply supported beam and give a maximum moment of 810 kilonewton meter. Okay, so here maximum moment will be 810 kilonewton meter when supported by the UDL of 5 kilonewton per meter. Okay, so if the UDL is applied over here, you can see suppose this is the span A and this is BAB. Here UDL is applied this 5 kilonewton. Okay, in this entire span AB. So the maximum moment is 810 kilonewton meter. So from here we can write, as we know, the maximum moment equals to 810 kilometer meter. As we know, the formula of moment equal to WL square 8. Okay, in the slope deflection and in so many moment distribution, we have done so many questions of bending moment. Okay, so when the UDL is applied, then the maximum moment will occur at a WL square by 8. Okay, this was the formula. Okay, in slope deflection and in moment distribution we have done. Okay, for the UDL we have to find out maximum bending moment, and which is calculated by the formula WL square by 8. Okay, so the maximum moment is given in this question and the formula is WL square by 8. So we just need to put the value M that is given in the question 810. So the value of M is 810 and W means this UDL is 5 kilonewton, so 5. L is not given in the question, so we have to find out the L by L square by 8. So we have to cross multiply this and divide by 5. So 810 into 8 divided by 5. Okay, this is L square, so we need to take the root of value. So after that you will get L equals to 36 meter. Okay, so in this way we can calculate the value of L, that is 36 kilonewton. And now in the question it is already said that you can see here the height of the span is 1/10. Okay, so this is given in the question. Okay, the center line is how much? 1/10. It means this height will be L upon 10. So means 36 upon 10 means how much? 3.6 meter. Okay, so now let's calculate this one. Okay, so the value of uh, h of this arch will be L upon 10, that is 1/10 of the span. It means 36 by 10, so this value will be 3.6 meter. Now you can see here, if you draw the question, and another part is also given in the question, so let's read first. So again, in the question, the arch was designed to carry UBL. This arch is going to design UBL of 4 km on the left span. Okay, with the highest ordinate at a crown. Calculate the suitable horizontal thrust. Okay, so in very first, the given question was this, and we have calculated from here the value of H and L. Now we have a second case. This was in the first case. Okay, maximum moment was given, so from that condition we calculated the value of H and L. Now in another case, okay, in second case we have to design the arch having UDL 4 km per meter. Okay, and this UVL is acting from the left side, so it can be drawn as here. You can see, as we have calculated the value of this center rise is 3.6, and the length, that is 36. You can see here, length we have calculated 36 meter. Okay, and from here you can see the UDL is applied in the entire span of the length, left side, from left side. So you can see here we have a two different part. This one is right, this one is left side. So UDL is acting over here. How much? 4 kN per meter in distance 36. Half of 36 means this is acting for the this here to here, that is 36 by 2, uh, 18 meter. This UBL is acting. Okay, so now we need to calculate the value of BA and BB. This is our first case. Then we need to calculate the value of horizontal thrust, that is H. So first calculate the value of BA and BB. For this you can see here, this BA and BA is acting upward, so summation of Fy equal to 0, we have to take upward value equal to 0. So BA plus BB, okay, this is upward, so taken positive, is equals to, and this load you can see here, this load is acting here downward. Okay, so it can be calculated 4 kN. It can be calculated half of this 18 into 4. We have to multiply this UBL by the length, and we have to divide by 2, because this is the UDL case, UBL case. In UBL we have to divide by 2, so we just divide by 2, and finally we get the formula BA plus BB equals to equation, that is 36. Okay, because 4 by 2 means 2, 18 into 2 equal to 16, so we get the equation 1. Now we have to take the moment at A. You can take moment about B also. Now summation of moment about A equals to 0. So let's take this. Okay, so in this case you can see here moment about A equal to 0. So for this you can see this load is acting here, it means clockwise, so it is taken positive. So half of 1 by 2, this 4 into 18, this is load, and distance you can see here, from here to here distance will be 2 by 3. This load is acting from A, 2 by 3 of this length, that is value of L is this 18. So 2 by 3 of this 18, this is the length, this is force into distance, that is moment. Now you can see here this is clockwise, so it is positive, and another force is applied, this BB is also applied above, but you can see here this is the anti-clockwise, so it should be taken negative. So minus BB, that is the load, and distance from A to this load distance is 36, So BB into 36. From here, after calculation, we will get the value of this BB. Okay, and finally we get the value of BB is 12 kilometer. Okay, and after putting this value in this equation, we get B equal to how much? 24 kilometer. So the value of BA is 24 kilometer and the value of BB is 12 kilometer. So we have calculated these two value. Now, as we know, the formula of, let's see, in very first we have the formula of horizontal thrust equals to this one. Okay, this one is the formula. Okay, integration m dash y dx by a by integration y square dx by a. Okay, so if we can calculate the value of this numerator part and this denominator part, then we can easily put the value of this in this formula and this value like this, and we can calculate horizontal thrust, that is 57.20 kilonewton. Okay, so for this okay, we need to calculate this numerator part and this denominator part. Okay, so first calculate the value of this denominator part, it will be easy. So for the formula integration y square dx by y, we know the formula of y. You can see here. Okay, so first calculate these two value m dash and this y. Okay, then we have to calculate this y square dx. So for this, first we need to calculate y. So the formula of y is, you can see here, 4hx l minus x by l square, where h is the height of this entire hinge arch and this l will be length of the arch. So for h we have calculated value of h is 3.6 and x, we need to take x as usual, and l, the value of l is 36, you can see here, and x we don't need to take any value, about 0.8x. Okay, we have to write as usual by l. L square means 36 square. So finally we get the value of y, that is x into 36 minus x by 90. Okay, so we have calculated the value of y. Now we need to calculate this value m dash. Okay, and this denominator part. So first calculate this denominator part. So for this denominator part we have directly formula, so we can apply the formula directly. So you can see here, whenever the UBL is applied, then we can use directly formula. This y square ds equal to 8 by 15, how much? 8 by 15 h square l by ei. Okay, this is our formula for the calculation of this y square ds. For calculation of this part, that is denominator part, we can directly use this formula, 8 by 15 h square l by ei. This is for the half span. You can see here in this question, this UBL is acting only this half span. So for this we need to calculate, we have to use this formula. Okay, so the h value of h is 3.6, so h square 3.6 square into l means 36 by ei. So finally we get this value. Okay, and this value is this one, 248.83. So we have calculated denominator part. Now we need to calculate, you can see here in this equation, we have to calculate this numerator and denominator part. We have calculated this by directly applying the formula, and we have also calculated the value of y. Now we need to calculate the value of m dash. So we need to understand what is the m dash in very first. So m dash, we need to carry out the moment, okay, for this individual section. You can see here we have total a to b, you can see here 4 AB section, and for this half section here to here, and after we need to calculate the moment for this section. Okay, so for this, let us separate this part in the tabular form. So you can see here we have separated two different for this AC member and BC. From here to here, this is AC, and from here to here, this is B, and this is C. So this will be BC. So from left to right, you can see here, our limit is 0 to 18 because this is 0 to 18. Okay, and for this BC also, this is 0 to 18. Okay, and for the origin, we are going to take half of this span. You can see here, from here to here we are going to take this. So origin of moment we are going to calculate at a point here. Okay, and for this B, from right side we are going to calculate the moment. So for this BC section, our origin will be B, and for this AC member, our origin will be A. Okay, from left side A, from right side B. Now we need to calculate the moment. Okay, so very first you can see here, okay, so for this first calculate the moment at section X. Okay, this is, we are going to calculate the moment at section this point, okay, which is X distance from this point B. So it can be calculated. You can see here 12 into this will be anti-clockwise. Okay, so anti-clockwise will be taken for the, this is right side. Okay, from right side anti-clockwise will be positive. It means this 12 into this distance X for the section, this section 12 into X, this is anti-clockwise, this load is acting anti-clockwise, so it is taken positive. Now for this AC, okay, AC, our origin is A. So for this, for the AC we have to take clockwise positive, and for this BC, okay, for here to here we have to take anti-clockwise positive. So this is the opposite. For left side clockwise positive, for from right side anti-clockwise is positive. Okay, so this is 12x, this is anti-clockwise, so it is taken positive. Now we need to calculate this for the member AC. Okay, so let us take an section here, this is distance X. Okay, so the total load will be this one, 4 into 18. Okay, so 4 into 18 because this is 18, and this will be 4 into 18, and this we have to do half because this is the UVL, so half this, and 1 by 2, 4 into 18 into X, so it means this value will be 24x. Okay, so this is clockwise, so we can see here this will be acting like this. This is act moment from here like this, so this is clockwise, so it is taken positive, that is 24x. Okay, so 24x minus 0.03, you can see here. Okay, sorry, just you need to understand one more thing. Okay, you can see here, first remove this one. Okay, so as similar to as right side we have taken a section X, in left side also we need to take section X. Okay, from here to here X, and we need to calculate the moment over here. Due to this, okay, here is two different load is applied. First load, that is 24 kilonewton, which is acting this like here, this is clockwise, so this 24 and this is the distance X, so moment will be 24 into X, so we have calculated this. And now due to this section here also load is acting, which is downward, this is also rotating this AB portion in clockwise direction. Okay, so for this you can see here. Okay, so first let's see this, we are going to calculate the moment at section X. Okay, from here to here section X, we need to calculate the moment over here. Okay, and now you can see this, due to this part, this UVL is acting here, so it means in respect to this point, this will be acting like this, so this will be anti-clockwise, so it is taken minus. So you can see here this is taken minus 0.037 x cube. So x cube means this 0.03 means this 4 into span x by 2, okay, and the distance that is x. So this will be 4 into x, 4 into x, and the distance is taken L by 3. Okay, so it can be taken x by 3. So in overall, so you can see here, this will be our load part and this will be distance acting. So our load is here. So this value will be 0.037. Okay, and you can see here this is acting at a distance x. Okay, so we need to multiply this again by x, so will be x will be x cube. So from here you can see here, due to these two load, first one this load and another due to this UVL load, we have calculated this moment. Okay, now we just need to put this value in the given equation. So finally we have two different section. First one is this one, so this is acting for my for the denominator. In the place of m dash, we have to take this value from 0 to 18 and this 12x. Okay, this 12x from 0 to 18 again. Okay, so we have to just take this two moment for this m dash part. Okay, so finally this value is here and this 12x will be taken here. So this formula will be taken for this individually, for upper part, that is this one. Okay, and for this lower part, m dash means 12x. Okay, and m dash y means this part, and dx by e. So finally we get the value of m dash dx by e, this one. Okay, and now we just need to put this value in the given equation and finally we get the answer. So the value of this m dash will be this one. So just put over here in this formula, and we have already calculated y square dx by ei, that is this. So from here we can get horizontal thrust, that is 57.201 kilonewton meter. Okay, so in this way we can calculate this horizontal thrust. Thanks for watching. Please do like, share and subscribe. See you in next video.